So, I'm Chris Ferry, I'm the CTO of StorMagic, and in this talk I'm going to give you a bit of technical background to our product SvSAN. So start off just talking about a little bit about the architecture of what we've got. So what we've got is a storage stack that typically runs as a virtual storage appliance. The software itself is based on Linux, although all of the storage features, all of the storage software is software that's been developed by StorMagic. Because it's running on Linux, it means we can run it on pretty much any platform we want. So we can run as a virtual storage appliance in a virtual machine on a hypervisor. We're also capable of running on bare metal, and we've got customers doing both. What we are aiming to do with this is to produce a very flexible stack architecture that would allow us to offer a range of storage features. So the architecture that we sort of came up with is a very modular architecture. At the top of our stack, we've got our iSCSI target module, which sits above a SCSI target module. So the iSCSI target implements the iSCSI protocol, the SCSI target implements the SCSI protocol. If we want to add other storage protocols in there, such as FCOE or something like that, it's very easy for us to do. We just write an FCOE target that sits up at the top of the stack.
Do you have a demand for any other protocols at the moment? Are you working on anything?
We're not actively working on any others at the moment. FCOE is one that's come up several times. There's a few partners that mention it, but there's never been anything strong enough, strong enough demand to sort of warrant doing it. There's always been more important things to do.
Mm-hmm. Especially in the remote sites.
Did you write your own, were you saying something? Did you write your own iSCSI stack, or are you using something like SCST?
No, we wrote it's all written by StorMagic.
What's the reason for that? I mean, I'm guessing you're going to get more efficiencies and better performance.
So when we started, I think Hans said we started doing this back in 2006. We'd previously done an iSCSI implementation in our previous company, SvSAN. So we'd learnt a bit about it. In fact, we had one of the I think in Comdex in 2000, we showed one of the very first iSCSI target implementations. So it's something that we knew about anyway. Mm-hmm. When we started, we looked at existing ones. We looked at the Linux open source iSCSI target, and very quickly we found there were too many shortcomings. Now, quite a lot of those shortcomings have been addressed over the years. The shortcomings were we didn't feel it was modular enough at the time. There wasn't a good enough separation out of the iSCSI and SCSI features. We particularly wanted to support Windows environments where things like SCSI persistent reservations were required. They weren't available at that time. They are now, but they weren't available at that time in the Linux products. Manageability was very important, as well as the management interface. The Linux iSCSI target is not brilliant. It's all based on configuration files, so you have to create the configuration files and everything, whereas what we wanted is API-based management, so we could basically sort of call everything from the relevant APIs. So they were the sorts of reasons that we decided to develop our own. And from the point of view of efficiency and architecture, we found that by running it all as a sort of stack in user space and making use of the Linux asynchronous I/O subsystem, which gives you direct copy, zero copy direct I/O to storage devices, we can make it just as efficient as a kernel implementation. When we've generally done benchmarking against other iSCSI implementations, we usually come out top or pretty close to the top.
Do you take advantage of any offloads of TCP/IP or iSCSI, any of that kind of stuff?
Well, we can if the network card's got things like TCP checksum offload, then we can take advantage of that. We're not taking advantage of any iSCSI offload at the moment.
Why? Just curious.
Just hasn't been a need to do it, and it's also more complex. If you're running as a VSA in a virtual machine, then you haven't got the direct access to the hardware unless you do a PCI mapping, and the users generally don't want to do PCI mapping.
Right. Okay.
Okay, so the modular architecture then. So below that, then we've typically got our synchronous mirroring module, we've got our SSD caching module, we've got a migrator module. And then we've got remote and local I/O modules. The local I/O one uses the Linux asynchronous I/O that I mentioned just now. The remote one effectively means we can send I/O to any other of our VSAs that's out there. So that's used by the synchronous mirroring.
So you've got an SSD caching layer there.
Yes.
But when you're synchronously mirroring between two nodes, the data's got to be, it doesn't get acknowledged when it's in the SSD caching layer then?
Yes, because the SSD cache is persistent storage. Basically, it's got to be written to some non-volatile storage. Yeah. That's the important thing.
Okay, so that's the SSD cache. It doesn't have to necessarily go to a 5400.
No, that's right.
Right. Okay.
The SSD caching is optional.
Yeah.
Yeah.
Ah, right. Okay.
So, and we only released that a couple of months ago. So, most of our customers are not using SSD caching at the moment. So, there've been lots of questions about synchronous mirroring, so now we'll get into it in a little bit of detail. So as I've said already, we create iSCSI LUNs, which are mirrors, and you can have any combination of mirrors across any combination of nodes. And it's an active-active synchronous mirror, which means you can write to either side of the mirror. They are both completely peers. Internally, one of them will take leadership of the mirror, but it's just that's just an internal feature, and that leadership can change. The way we present it is at the SCSI layer, we present it as a multi-ported SCSI device. So we just basically use sort of standard SCSI protocol. It's a device with multiple ports. Some ports go to one side of the mirror, some ports go to the other side of the mirror. We report the port state using standard SCSI commands, the report target port groups command, and the SCSI Allure protocol, asymmetric logical unit access. So basically, it's all completely standards based. What this means is you don't need any special software running on the host. So we basically work with standard multipathing software on the host. The software on the host simply sees the multi-ported SCSI device. If one side of the mirror fails for any reason, then it simply sees a path failure to one side of the mirror and uses its standard path failover software to talk to the other side of the mirror. You can have multiple ports to both sides of the mirror as well. It's not just two ports. You could have two to one side of the mirror and two to the other side if you want to get redundancy or extra bandwidth or whatever. So as I say, it's standard multipathing software. On ESX, it's just the native multipathing module. We haven't had to write our own multipathing PSA module or anything like that. If you're in a Microsoft environment, the standard Windows MPIO DSM, that does the same job. So there's just a diagram there showing how you can have multiple hosts. You don't just have to have two hosts accessing the mirror. You could have 3 hosts, 4 hosts, whatever. Any host that can see the iSCSI target can access it and use its multipathing software. Okay, so
on the host side, do you have any recommended best practices about MPIO?
A lot of customers like to just use the local path as the primary path. Yeah. So you can do a sort of round robin, or you can do a local path. In theory, if you're using the local path, then that will mean that all of your reads go locally, and so that should be faster than going outside on the physical network. The reality is sometimes it's not faster, and we don't really understand why that is, but it's something to do with the internals of VMware's virtual networking.
But you don't mind,
we don't
customers
mind.
Can use either?
No.
Cool.
Okay, so the quorum requirement. Now, if you've got a distributed device, then you've always got the possibility of what's called split brain. What happens if the two sides of the device somehow lose connectivity? They must do the right thing. So that could be the network connection between the two sides fails, or it could be a situation where one side goes down, then later on the other side goes down, and the side that went down first comes back up. That side is now out of date. It needs to know it's out of date. So you need a way of handling every possible failure situation. So the goal here is that the system should be capable of withstanding any single failure and doing the right thing in the case of any multiple failure. Now, it might go offline if you've got a multiple failure. Obviously, if both sides of the mirror go down, then it's got to go offline, but there should be no sort of data corruption, and as long as the disk storage is protected in some way with RAID, there should be no loss of data. So logically, if you go through this, logically the only way you can do it is with having some sort of third-party quorum service, some sort of tiebreaker. So the way this works is this tiebreaker is actually a simple piece of software. It's not a piece of hardware. It's just a software service that can effectively run anywhere. So it can run on a Windows server as a Windows service. It can run on a Linux server as a Linux daemon. It can run locally on the local area network, but it can also run remotely over a wide area network. The amount of data that's sent to this Quorum service is tiny. It's basically any change in the mirror state or configuration. So if one side of the mirror becomes unsynchronized, that mirror state needs to be sort of sent to the Quorum service. If there's a change in configuration of the mirror, somebody adds a new host into an access control list, that needs to be sort of maintained there. But that's really all the data there is. Apart from that, there's just a heartbeat a message that's sent across every few seconds. What this means is that the bandwidth and latency requirements for the neutral storage service are very, very low. You can run it remotely over a very low bandwidth, unreliable connection. If you get glitches in it, the connection dropping out for a second or two, then coming back, then it's not going to affect availability or anything like that. You can even run it on a very lightweight device like a Raspberry Pi or something like that. We've got an ARM version of it.
So you say that your Quorum service can be on a different site?
Yes.
I know I'm asking the wrong person here, but why would HP and Store Virtual not support a configuration like that?
Because they came from a different place. If you look at the background, what Left Hand were originally doing, they were originally aimed at the data center, at high performance environments. So if you look at some of the original things that they were trying to do, they were providing high performance striping across large numbers of physical servers, and that's what their solution was architected to do. We started from the other end saying we wanted something that would start small and scale up.
But how hard would it be for them to say, okay, in an edge of the enterprise?
It's software, you can always do it.
Yeah.
You can do it, it's how long it takes to do.
Yeah.
If the Quorum service is really not getting any portion of the data that's being written, how can it determine which of the two vSAN VSAs is actually correct?
Because any state change has to get reported to it. So basically,
even if the VSA goes down, how does that get reported to the Quorum?
So basically, there is a mirror. The mirror state is in the data structure. That mirror state basically sort of says whether each side of the mirror is synchronized. So at the point where one side of the mirror goes offline, then the other side of the mirror will remain online so long as it can talk to the Quorum service, and it will change the state of the mirror to say, let's call it A and B. Say B's gone offline, it will change the state of the mirror to say A is synchronized, B is unsynchronized, and send that to the Quorum service. So the Quorum service now knows that B is unsynchronized. So if B comes back and tries to talk to the Quorum service, then the Quorum service will say, no, you're unsynchronized, stay down.
So it's really the VSAs detect that there's a problem and they just report up to the Quorum server.
Yeah, so the Quorum service is really passive. It participates in elections, so basically there is always a leader to the mirror. So to bring a mirror online, a leader must get elected. So that means that at least 2 out of 3 of the nodes must be online. So either one side of the mirror in the Quorum service, or both sides of the mirror. When one side comes online, it will first of all see if there's already a leader to the mirror. If there is, it accepts the leadership and joins the mirror. If there's not, it stands for election. And if one other party agrees to that, then it becomes the leader. The Quorum service will know who the active leader is.
Let's hope it's Republican.
Sorry? Yeah. So there's loads of failure states that you can get, and the amount of testing that goes into.
And the leadership is on a virtual disk by virtual disk basis.
Yeah, that's right.
Could be a pair here, a pair there, or something like that.
Yeah. It's actually split out within the architecture of the stack. Then there's actually what's called a cluster service, which actually supports arbitrary size clusters and allows leadership of the clusters. And what we do is we associate a cluster with each mirror.
And the Quorum service could run on either of the VSAs, or
yes, the Quorum service could be another VSA as well. So you could have 3 VSAs there, a mirror between A and B with C acting as the Quorum. And you can change the Quorum service as well. Yeah, you could run this Quorum service in a virtual machine as well, sort of at a data center, so that that virtual machine could fail over.
Service for virtual disk pair, or?
One Quorum service can act as the Quorum service for thousands of virtual disks. So, the situation we've got at some of our big sort of customers where they've got thousands of sites is they may just have one or two Quorum services servicing those thousands of sites.
Someplace else.
Yeah.
What happens when the Quorum service goes down?
So if the Quorum service goes down, then as long as the two sides of the mirror are up, then they'll stay up. If one side of the mirror then goes down, then the mirror will go offline, because then you can't determine what's going on.
So do they just stop?
So then they just stop, yeah.
Okay, so if this is an edge location and it's a single switch and the switch dies, everything's going to stop at that point. Okay.
Yeah. Now, there is an optimization that we've put in there, because if you actually look at the most likely sorts of failure you're going to get, you may have an unreliable connection to your neutral storage host, which goes up and down. So you could potentially periodically lose connectivity. Sorry, neutral storage Quorum services, just different terms we use. So you could momentarily lose connection to the neutral storage, to the Quorum service. Now, if that happens, if that happens when both sides are up, that's fine. If that happens when one side of the mirror has gone down, then potentially you could lose your storage, your storage out at the edge. That could go offline. But there's a nice optimization you can do there, where if one side of the mirror fails, then you let the Quorum service know that, and once you know the Quorum service knows that, then you can withstand a failure of the Quorum service. So the most likely failure situations you're going to get is a failure of one side of the mirror with occasional failures of the Quorum service, and that optimization handles that failure. So another issue you need to consider is mirror resynchronization. So you've got the two sides of the mirror. Everything's fine. One side of the mirror goes offline for some reason. It might just be that you're doing some maintenance on the server and you need to reboot the physical server it's on, or something like that. It may just be down for only a minute or two. Now, if you're talking about mirrors with maybe many terabytes of storage on there, then if you were to do a full resynchronization every time that happens, then that could take many hours. What you really need to do is a fast resynchronization. You need to just track the changes that happen to the surviving side of the mirror while the other side of the mirror is offline, and once the failed side of the mirror comes back online, then you just need to replay those changes. So the way we do that is we basically maintain a journal when one side of the mirror is down, which just tracks the changes that happen to the other side of the mirror, and it's purely a metadata journal. So it's just got logical block address, block count of all the changes that happen to the mirror. When the surviving side of the mirror comes back online, then all we need to do is basically read that journal. What we then do is we turn it into an ordered extent list so that we can effectively near sequentially resynchronize the mirror, so we can do a very fast resynchronization. And often what you find in these environments, if somebody reboots the server for some reason, it resynchronizes within a few seconds. Okay, so the last part I've got, we're talking about management and monitoring. This has come up a bit. We've already discussed some of this. So we've got integration with some standard management frameworks. So if we're in a VMware environment, we've got integration with vCenter. As I said before, this is optional integration. You can run without it. If you've got it, it gives you extra features. We've also got some integration with Microsoft System Center, which we're using for the Hyper-V product. One of the most important things we've got, which is very important when you're going out to these distributed environments, is a good range of scripting tools, so that you can actually automatically script the deployment out to the sites. So basically what happens is the customer develops effectively a recipe. This is what I want every site to look like, with just some parametric differences for each site. They just set up a script and run that script to deploy all of their sites. So, the retail customer we were talking about with 2,000 odd sites, when they were doing deployment, they were deploying up to 30 sites in one night, which is quite a few. These scripting tools, they're basically available as PowerShell commandlets, so very easy to use. The other part of it is monitoring, and again, monitoring using standard tools. So if something goes wrong, you want to know that something's gone wrong. One thing we've supported for a while is SNMP, so you can set up SNMP traps and that sort of thing, see what's going on. And recently we've just added support for the Microsoft System Center Operations Manager. So we've got a management pack for that, which means that you can basically monitor thousands of sites from SCOM and see if anything goes wrong at any of those sites. So normally everything will be in a good normal state. If if one of the mirrors, say one side of the mirror fails, the other side will remain online, but the state of that system will go into a warning state to let the admins know something's going on there. If you get a complete failure at one site, then it will go into an error state, and you'll immediately see that through SCOM. And you can use whatever SCOM tools you use to sort of monitor the sites and see what's going on. Another part of what we do is keep pretty comprehensive usage statistics. So we basically monitor how much storage is being used. So we record the number of IOs, the amount of data written at several levels of granularity. So we record it every minute, so you can basically see pretty much in a real-time display how heavily any particular volume is being used. So we basically sort of store statistics per minute for 24 hours. We also store daily statistics for a year, so you can basically see how heavily things have been used over the previous year, and we give extra granularity in there. Which hosts were actually doing the IOs, so you can break it down to that. Which network interfaces were being used and that sort of thing. So you can get good visibility into what's really going on in the system. How the various sort of servers are actually using the storage.
Is that configurable? Let's say I want to keep my minute stats for 3 months.
No, it's not configurable.
At what point do the minute stats roll up?
So the minute stats roll round every 24 hours.
Well, that sucks.
Yeah, but the daily stats roll round every year. So you can see how heavily things have been used, and we've also got monthly stats, which hang on. Just trying to remember what it is. The monthly stats roll round every month, and I think they give granularity to an hour, so you can see sort of usage per hour for the last month.
I can't remember the last time I ever had to do a performance analysis, and I only needed 1 day's worth of
right. What you
stats.
can do is you can download the statistics to an Excel spreadsheet. So if you wanted a longer period, you could basically, if you wanted it to the 1 minute granularity, then you could basically download those every day. And that will give you a longer period.
And can you script that download?
In principle, yes. So that's a good point. We should probably make that easier. At the moment, that's generally done from the web GUI, but because of the way our interfaces work, anything that web GUI can do is done via a lower level API, and that lower level API can in principle be scripted. So.
And then when you say Excel, do you mean CSV or actual?
CSV.
Okay.
Yeah, because whenever we know something's going to roll off at midnight, we grab it at 11:59 and say, dump it all.
Yeah. In principle, yes, and I think it's a good point. We should make it easier.
You should make that easier. It's little things like that
Yeah.
all the time that would make our lives so much easier. No offense, but you never do. And we come away thinking, it's like, how much engineering effort is that?
Yeah, I know.
And everybody would love it.
It's hearing about it from people, though. Wow. So, a lot of these things, you talk to the customers, oh, we really want that. And it's something you never thought of. As a developer, you're in a different position to the customer. We've got a product manager who's got experience out in the field, and that helps. But, there's nothing like getting feedback from real customers and real users.
Well, that's good feedback already, thank you.
Yeah. I mean, to be honest, the scripting tools we've got were very minimal until we started working with a big customer, and a lot of the tools we developed were based on the feedback we were getting from the customer as to what they wanted.
Would that scripting capability be satisfactory to you, or would you're shaking your head? You
Is
want
there
to see
any
more?
way to go real time with the stats, sort of like a stat on a NetApp or any of that, or down to a couple 2-5 second granularity?
Well, it could be done. Tell me why you want it. I'd be very interested to know.
That's a common thing I have to look at is what's the real usage? Because even looking at 1 minute granularity, I could have lost data for 1,000, 2,000 transactions that I wouldn't see, but right when I see it at that 1 minute time period.
Well, I mean, what you're seeing is everything that's happened in the last minute. So it's
Averages suck when you look at performance.
Sorry?
Averages suck when you look at performance.
Yeah. There's no reason it couldn't be done. Again, it's sort of, this again is a fairly new feature that we came out a couple of months ago in the last release of our product. So, we're still getting feedback on that. The actual granularity levels that we put in, they were chosen by us because they seemed sensible at the time. But if high levels of granularity are important, then it's trivial to add them.
Or at least being able to say, all right, I don't want the average, I want the mean, or I want the max of this 1 minute period. For a 10-second interval. So I can do that with competitors.
Yeah, I mean, you can get instantaneous ones as well. I mean, from system start, we record the counts for sort of any target. So, and you can get those counts at any time. So you could just sort of interrogate it as frequently as you wanted. So if you were getting statistics for a second, then you'd basically get 3,600 data points per hour, and 86,400 per day. So, that's the sort of level that you'd like.
Even if you couldn't do it real time, if you could say, oh, I need it now, give me everything since midnight or whatever.
Yeah.
And then 5 minutes later, I can say, give it to me again. And
you get that with the minute granularity because you can see everything for the sort of last, each minute from over the last 24 hours.
Is there a way to say, in a scriptable fashion, give me all the data either since midnight or since some starting point until now?
Yeah, well, that's there. Now. Yeah, you can get that. Okay. You can get that from this. From
as long as it's scriptable, so I can trigger it.
Yeah.
That'd be good.
Yeah. Okay. So the other thing you can do is you can use that to sort of help make decisions about migration. So I sort of tried to do a demo of the migration stuff earlier on. A bit unreadable, but the point about this is you can identify the hotspots using the statistics. So if you've got particular iSCSI LUNs that are being heavily used and others that are lightly used, it might mean that some of your VSAs are very heavily loaded, other VSAs are lightly loaded. What you want to do is you want to try and balance things around, and so you can use the statistic to do that. So that's where you would maybe be using the daily statistics and just have a look at how heavily things have been used over a period of time, over the last sort of few weeks, few months, whatever, and identify where the hotspots are, and based on those hotspots you could then dynamically migrate stuff across to new servers.
So I mean, you could migrate one half of a virtual disk.
That's right.
Pair to another VSA.
Yeah. One half or both halves if you wanted. Now, one of the ideas we've got is to actually sort of start doing some automation around that. So use the statistics to sort of, run through what-if scenarios and make suggestions to users so we can try and do an automatic rebalancing of loads if you've got larger numbers of VSAs, in a data center or something like that.
Did your statistics distinguish between the two halves of the pair?
Yes. They distinguish between two halves of the pairs. They distinguish between individual hosts or servers that are accessing the mirror, and actually even distinguish between the different network ports that were used. Okay, so that's all I've got on the technical stuff, but if there's any more questions, I'd be happy to answer them.
Do you guys have any benchmarks on this stuff?
We've got some. We've done one or two sort of white papers on performance, and we've got some internal studies. We did some internal studies on SSD performance to sort of see really what the limits of our performance were, where the bottlenecks were, where we could improve performance by.
You guys have any ballpark IOPS or numbers and so on?
It's pretty tough because you never know what kind of hardware it's going to be running on.
That's it. That's the thing. There are so many things that can affect performance. Everything in the infrastructure, the host and so forth and all of that. When you sort of start homing in on the VSA, then the things that are going to affect performance there, it could be the network interfaces, they could be the limiting factor. Usually it's the underlying disks, if it's conventional hard disk drives at least. And finally, it could be the software stack itself if it's maxing out the CPU. Now, what we find is that you don't really max out the CPU until you start getting up to somewhere like sort of 50, 60, 70k IOPS. That's
That's
random
actually
4K
decent numbers,
IOPS,
actually.
which are decent numbers,
Yeah,
yeah.
very decent
And if that happens, then you can start winding that up to 100, 150k IOPS by just adding cores to the virtual machine that the VSA is running in.
I'd like to actually get Hans' opinion. This one you were actually resisting from using the buzzword, right? Hyperconvergence. What's your take on that?
Why I didn't use the word hyperconvergence?
Right.
Because I think it's an overplayed word, right?
Okay.
And it's, you look at what we're doing, yes, it is hyperconvergence. It's exactly what it is, but that's not what the customer is actually looking for. That's not the problem the customer is looking to get solved.
Sure.
So I rather use the expressions which are related to what is the problem that the customer wants rather than what is the latest buzzword that's going around.
Okay. I wouldn't consider this hyperconvergence because
well,
I'm not going to them to
That's
buy
right.
compute.
Yeah.
So I don't call this a hyperconverged.
Well, that means you don't. Does that mean you don't call Max the hyperconverged?
No, I wouldn't.
Okay, they would.
Okay.
So, but
You almost answered my question by saying that as well.
Yeah.
That it's an overused word. As is software-defined storage. Well, we've been doing software-defined storage for many, many years, but now it's the latest. It's one of the latest buzzwords. It sounds good.
Well, and customers don't buy buzzwords; they buy solutions to problems.
Correct.
So the typical environment is like a two-server environment where the storage is a VSA and it's running hypervisor, so it can run the applications as well in those solutions. So, yeah.
Yep.
Smells like hyperconvergence.
It very definitely is, and some of our partners are actually selling our technology as hyperconvergence. I don't care what they call it as long as they sell it.
Yeah, as long as they sell it, yeah.
Hey, what are your thoughts on architecturally on a VSA design versus baking it?
Nigel!
What? Versus bake it into the kernel like vSAN. What? Really?
I'll do this on
The
Twitter.
VSA certainly got more flexibility. The one hit you take, or the big hit you take running in a VSA, is when you're talking to the local host, you're still going over a network protocol, over iSCSI. So you take a performance hit if you're doing it over iSCSI.
Can I have a VSA, one running in VMware, another in Hyper-V?
Our stuff would support that. I'm not sure I'd recommend it, but yeah.
Just showing that this is going to work with any iSCSI compatible
Oh, yes, it
host, and
will,
it's not
yeah.
baked in, locking you into a single vendor. It's like, why would you ever want to use AWS and Azure? Some people say, what's the point? When others are like, I've been hit once, I want to split it up.
If you want to change hypervisors as well, move away from ESXi to Hyper-V, you could have one node as each, drop the ESXi one, bring up a new Hyper-V.
Or a company makes an acquisition, the first company's all on one, the other company's all on the other, you want to merge them together.
And we are seeing a lot of sites that are actually beginning to be more mixed hypervisor sites as well, not necessarily in the same application, but within the site for different applications, they're using different hypervisors.
Really?
A lot more. So we've seen in the last, a year ago, it was all VMware. In the last year, in our pipeline's now about 30% Hyper-V. And from the point of view of people talking, there's a lot more asking us about KVM. Nobody's asked us to provide on KVM, but a lot of them are saying to us,
we have had one or two.
actually, you're right. Yeah, you're right. There's two, but they've moved away from KVM. Those are the ones you're thinking of. But we're seeing a lot more saying, well, in a year's time, we could be seeing ourselves using KVM.
So these sites that are running multiple hypervisors then, are they in a state of flux where they're moving from one hypervisor to another, or are they saying, right, we have a tier 1 hypervisor for our tier 1 apps and a lower tier hypervisor for other apps?
Not necessarily. So they're not necessarily saying, well, this hypervisor is better for our tier 1. They're just saying they may have been using one particular hypervisor for a long period of time, and they've now other applications that they're running, and they've actually built a different environment with a different hypervisor for those applications.
Yeah, I mean, we've heard, people complaining about VMware pricing and wanting to move away from VMware because of that.
Yeah.
And there is increasing interest in KVM. I mean, for us, KVM is an interesting one because we're based on Linux. We could potentially run natively on KVM. So, that could be an interesting solution. But at the moment, we haven't seen sufficient demand for it.
So there was a fifth section that we're going to speak about here, which is talking a bit about the competition, right? And I'm actually delighted we don't have time left, because to me it's always a fundamental rule that you don't talk about the competition. That to me it's bad business. But I would like to make a couple of points, and I'll just refer to it as, why do people go with StorMagic rather than go with the competition that's actually out there? What are the main differentiating features? Some of them have become obvious in what we said here already. So being able to have a simple 2-server configuration, we're actually fairly unique in being able to do that because of how we solve the split brain. That's one of the key things. Another one of the key things is that's very important is that centralized management, that you can very easily manage and monitor thousands of sites, whether it's through the management consoles or using the scripting capabilities or both. But another one that we haven't made quite obvious here is that with our type of architecture, you always know where your data is. That mightn't sound that important to you, but we actually have a couple of customers that have rejected scale-out type architectures that, for instance, vSAN has, because vSAN is very clever in allowing you in automatically moving the data to different places. In the type of implementations we're talking about, a lot of our customers will put one server at one side of the building, or a pair of servers, and another server or pair of servers at the other side of the building. They need to always make sure that there's copies of their data at both sides of the building. They need to have control over that. The reason they're doing this is because if the fire alarms and sprinklers go off on one side of the building and soak the servers, everything can fail over to the other side of the building. And they need to ensure that they always know where the data is. And it's actually an Italian customer that first pointed this out to us, that he could not use vSAN because he had to make sure that he had that, I wouldn't call it campus, I call it building-wise, high availability, that he knew where his data was at all times.
Do you have a tool for capacity planning, single installations, and to let data to someone?
Well, all we've really got for that is the statistics I've already mentioned. So you can sort of gather the statistics on all of your targets, and that will show you trends. So if you've got the statistics of daily throughput per year. Sorry?
So capacity, the typical customers, we don't get demand for that, because typically they have an application, or they have applications that they already know what they're going to do. They already know the capacity they require, and they're going to continue running on that. Often they'll buy from us at higher capacity in case they need it in the future, but they know exactly what they're going to do in the first place.
Yeah, you see, the problem is we're block level storage. So, we basically give storage which gets formatted up as a file system. We've got no visibility into how full that file system is. And that's what you really need for capacity planning. And
quite surprisingly, in most of these applications, the requirement doesn't grow. So, most data center type applications, you're going to require more and more storage. These are set and forget environments. The amount of data that they're actually handling remains relatively constant the whole time.